Okay, so this is 8.6, number 11, so we'll start from the beginning. Adele wants to compare the Earth and the Moon by creating spherical models. She's decided to represent Earth with a sphere that has a radius of 10. So I guess this is the Earth, and this is the Moon, right here. So if she's going to make the model of this being 10, you can kind of see a proportion here, I guess. So we have 6378.1 is related to 1737.4. And if I wanted to find out what the radius for the moon here, right? Radius for the moon, let's set up a proportion. So this has got to be 10. And the other one is going to be x. So if we solve for x, multiply, and then we'll have to divide again. So really this x is going up here, and this is going over there. So we have 17324 over on this side. And we have 6378.1x. Do that division, and let's see what we get for x here. Okay, so 17324 on 17324. Yeah, but I multiplied by 10. I'd multiplied by 10, so that's going to be now just 4. Divided by 6378.1. So 2.716 would be the new value here for x. 2.71. Now it says what radius the sphere should be used to represent the moon. So does it make sense that this 2.71 centimeters? Is that the answer for A? Good for A. Okay. So that's the answer for A. Check. B says determine the ratio that compares the circumference of the model of the Earth to the circumference of the model of the moon. Okay. So I guess the model, so we'll use the models. So if we have the Earth here, the circumference is the distance around, okay? Don't get confused with the area. And here's the moon. So we're comparing circumferences. So C is 2 pi r. That's how you find the circumference of a circle or of a sphere, which really the middle section would be just a perfect circle, right? So we've got circumference here is 2 times pi times 10. And over here is 2 times pi times 2.71. Okay, so again, get on your trusty calculator here. And what we'll do is we'll use the pi button whenever you can. So 2 times pi times 2.71. That's going to be, looks like this, 17.027. And the circumference here is going to be well, 2 times pi is about 6.28 times 10, so 62.8. Let's do that anyways. 2 pi times 10, 62.83. 2.83. So the ratio that compares those two circumferences, you simply divide those numbers. So let's give that a try. So that number is 62.83 divided by 17.02. Let's put as many decimal places as we can here. And we got 3.69. So for B, the ratio would be 3.6900 or so. So does that check out? Yeah? Okay. So C, okay, so sorry, was that the one you were asking about, B?
Yeah.
Okay. Sorry? Oh, okay. Oh, okay. So 3.69 or 3.7, I guess it is, right? All right, so determine the ratio that compares the surface area. Okay. So now circumference is a one-dimensional length, or is it a two-dimensional or a three-dimensional thing? What is that? It's on a sphere, okay? But I guess my question is, can we consider this as the scale factor? Is this the scale factor? And does it relate to, like, the radius? Because we know the difference in radii, or the proportion would be the scale factor. So does that work for circumference as well? Who did this question and would be able to comment on this? Did anyone use that as the scale factor right there? No? Okay. Well, what about this then? If this is the scale factor, circumference to circumference, which is a one dimension, so it should be okay. So what if we did 3.690 squared? because we're talking about areas.
Indoor recess this morning? Again, it will be an indoor recess this morning.
Indoor recess. You guys are excited about an indoor recess. You guys don't even have recess. Okay, just something to get excited about. All right. So 13.61. Is that the ratio of the areas there? You know? I think I have a solution manual here somewhere. So BC 13.5. Okay, so if they use 13 point or 3.6 or whatever, 13.5. So square it. So does that make sense? So this is an okay answer. Okay, grade 11s, quiet down, please. Hey. So that's C, and D, determine the ratio that compares the volumes. Okay, well, we know that the volumes are related by the cube of the scale factor, so 3.690 cubed. All right, and that should be the ratio. Let's just check it out. 50.24. So whatever the volumes are, they should be related by a factor of 50.24. And is that okay? So again, we're a little bit off from all of our calculations here, but we're using full decimals maybe early on the question and they didn't. So, and I used 2.71 as well, right? So yeah, so those numbers would be totally acceptable. Okay. So remember, if it's a single dimension, like the radius or circumference or diameter, the ratio between those single dimensions of similar objects would be the scale factor. Then anything area would be related by a square of that. Anything volume would be related by a cube of that. Okay? So does that answer everybody's questions about 11? All right, so I'll just maybe zoom out a little bit there so you can see the whole thing at once.